So today we are going to move on to looking at graphing f of x equals a times x minus h squared plus k. And what we call this is vertex form. So this form has a lot of advantages. It has a little bit of disadvantages sometimes too, but mostly advantages because, as you can see right there in the name, it's called vertex form. That means we're going to be able to find the vertex of our parabola really, really easy using this form. So we've been working on standard form, which, remember, is a times x squared plus bx plus c, and that a, b, and c, they all impact on what that quadratic function does, whether it moves up or down, left or right, shrink or stretch. But with vertex form, we're going to look at a few other things, and we're going to be able to find the vertex really easily and a few other things. So if we look here at our core concepts, when x is greater than 0, which as we know means positive, the graph is a horizontal translation, h units right of the graph. So when x is positive, that translation is going to move right. When h is negative, that is a horizontal translation. The absolute value units of the graph, left of the graph. So what that's going to look like for both of these is a times x minus squared, because this x minus squared is our form. So what this is really telling us is that our h is going to be the opposite of what it looks like in the formula, because what's going to happen is h and k become an ordered pair that becomes our vertex. So when it's moving right, when h is positive, it's moving that many units right. And it's going to look like this, a times x minus h squared. That's a little confusing, but once we get working on it, it'll make a little bit more sense. And down for this next one, because it's h is going to be negative, two negatives make a positive. So it's going to look like a times x plus h squared. So like I said, that is a little confusing right now, but once we start working with it, it will make a little bit more sense. And when we were using our standard form, we had a lot of steps to have to do to find that vertex form. If you remember, we had to use x equals negative b over 2a. That gave us our x value and our axis of symmetry, and then we had to plug in that x back into our function, which would give us the y value, and that's how we found the vertex. However, with this one, we're just going to be able to look at it and say, oh, look, I've got an h and a k. I know what that is. I've got my vertex. So now we have to think about, what is this k value doing over here to our graph? Well, when we have this vertex form and we have a k value, which is not the same as c. So if you want to put that, k does not equal c. It's not the same thing. And we'll talk about that again, or a little bit more a little bit later, and we'll see why. But just remember that k does not equal c. So k is not necessarily going to be your y-intercept. But what it does do is it moves your graph up or down. So if it's a positive, it's going to move your graph that many units up, and if it's negative, it's going to move your graph that many units down. Let's work on a few, and like I said, it'll start to make a little more sense once we really get going. So what we know here, we've got the vertex form, and we know that our vertex is hk, and that's really an x and a y value. And we know that our axis of symmetry is our x coordinate. And remember that with your axis of symmetry, it's not just 1 or 2 or 3. You always have to put that x equals 1, x equals 2, because it's not a point, it's a line. So we have to really specify that x goes up and down forever. It's going to be the axis of symmetry no matter how big or how small our graph. I'm so sorry, guys. No, how big our graph, our numbers are. So the first thing we look at here, we're just going to rewrite what our standard form looks like so we know what we can fill in. I'm sorry, not our standard form, our vertex form. So our vertex form again is a times h, x minus h squared plus k. Well, we know that our h is going to equal 2. And our k, well, we don't have one. So our k is going to equal 0. Now remember, like I said, this 2 is a positive 2 when we're looking at h, because we're not looking at the h minus 2, we're just looking at, or x minus 2, we're just looking at h, okay? So when it has a negative sign in front of it, our h is positive. When it has a positive sign in front of it, that means we've brought a negative with us and we've changed that negative to a positive right there. So we know, going back to number 1, we know our vertex is 2, 0, which makes our axis of symmetry x equals 2. Let's look at number 2. Well, right now we see that we have a negative out front, but to find our vertex and our axis of symmetry, we don't do anything with a out here. What we're going to look for is what does h equal and what does k equal. I just said how when we have a positive here, that means our h has brought a negative with it. So our h is a negative 8. Again, we don't have a k value out here, so our k is 0. Our vertex is negative 8, 0, and our axis of symmetry is x equals negative 8. So much easier than having to do all of that stuff like we did with standard form, right? So go ahead and pause it right here. Go ahead and work number 3 and 4 and come back and check and see if you are right. Welcome back. Let's check those answers. Remember, when we have a negative inside the parentheses, that makes our h a positive. Our k out here is positive, which gives us a 4. Makes our vertex 1, 4. Axis of symmetry, x equals 1. We've got a positive on the inside of our parentheses here, which makes that a negative, makes h equal negative 1, k to 5, and we have an axis of symmetry at x equals negative 1. So let's graph a few of these. Well, the good thing is that we have our vertex right in front of us. So we need to look for our vertex. That one's easy enough. We need to find our axis of symmetry. That one's pretty easy as well. And the third thing we'd have to look for is a second point somewhere on the graph so that we can finish out that parabola, because we can't make a parabola with just a vertex. So a lot of times that would be our y-intercept, but sometimes we might have to find a smaller point because we might not have the size in our graph, or our graph might not be big enough here to graph that big point out there. And what I want you to remember with this y-intercept, I said it before, C is not K. All right? Do not think that those are the same thing. So let's look at this first one. And we know that up here we have an h of negative 2 and a k of 0. That's going to give our vertex as negative 2, 0. Our axis of symmetry is x equals -2. So I'm going to go ahead and I'm going to draw this. And because I know that my vertex and my axis of symmetry is on the left side of the graph, I'm going to go ahead and I'm going to make my y-axis about right here. And I'm going to go ahead and I'm going to make my x-axis a little lower too, so that I have room to make my graph. Now, our axis of symmetry is -2, so 1, 2. We're going to mark that. And of course, these lines all keep going. So we have that axis of symmetry at -2. We have our vertex at -2 and 0. And what we're going to want to look for is some other point up here to finish graphing our parabola. Well, if I want to find my y-intercept, I would go ahead and I would put a 0 in for x, and 3, well, let's see, x plus 2 is 2, square that is 4, times 3 is 12. My graph does not go up that high. So I'm going to plug in a -1, because it's right there next to that -2. So I'm going to plug in a -1, and that's going to give us 3 times -1 plus 2, forget that parentheses there, squared. Then we have 3 times 1 squared, which is going to just give us 3. So that -1 is what we put in. So we go here, and then we move up 1, 2, 3. There's 1 point. We can reflect that around that axis of symmetry, and our parabola is right there. So that's pretty easy. Lots easier than all those steps in standard form. But what can we say about this? Well, comparing it to the parent function, it has a concave up, it opens up, so that's nothing different. But it does have a vertical stretch, which A has stayed the same, so it has a vertical stretch. I'm going to write this right here. Vertical stretch with a factor of 3. And it's also been translated 2 units to the left. So a translation, 2 units to the left. Let's move on to number 7. Go ahead and do number 6 on your own. Go ahead and move on down to number 7 with me. And let's take a look at what we're doing here. So we are not comparing a graph to our parent function. We are going to compare one graph to another. So what we're doing here is we have one graph, this f of x equals 3 times x plus 1 squared minus 1. Well, we know our hk, we know everything in there, but what we want to do is see what happens when we put it in for g of x, which is this f of x here plus 2. So let's write out g of x. G of x is going to equal 3. And so if g of x, we're just taking x plus 2. So we're just plugging in where this x right here needs to become this right here. So we're just plugging that in right there. So 3 times x plus 2, and then we have plus 1 squared minus 1. Combine some like terms, and we get x plus 3 squared minus 1. Now we can go ahead and find that vertex, because we have h equals -3 and k equals a -1. Our axis of symmetry is x equals -3. So to graph that, again, I'm going to move it over here because I know that it's going to be close to this edge. And I have a vertex of -3, 1, 2, 3, -1, come down right here, -3, -1. And I know my axis of symmetry, sorry, I should have done that before I plotted that. That's a dashed line. My lines sort of ran together. Don't forget your arrows here, because those lines keep on going. And again, we need some points up or down, depending on that A value. We need 2 more points to finish graphing that parabola. It's going to open up, and I'm going to go ahead and I'm going to put in a -2 because it's right there. It's that next point. I think it probably will be pretty close and it won't be too far off my graph. So if I put in a -2, that is going to give me a 3 times 1 squared minus 1. 1 squared is 1. 3 times 1 is 3 minus 1. That's going to give me a 2. So I have a -2 for my x value, -2 and 2, 1, 2. It's going to move up right there. I'm going to reflect that around that axis of symmetry and finish out that parabola. Now, if I had just graphed this f of x without really even doing too much, I know that my vertex is -1, -1. It would have been right there. So as you can see, when we added that 2, it went ahead and shifted it 2 more over to the left. So when we compare the two, it translated 2 to the left, and nothing else really happened. 2 units to the left. And that is based on g of x in relation to f of x. Let's move on to number 9 and talk about that one. This one we're kind of going backwards. We have been given some information and we need to write the equation. So just based on what it says here, if we draw a little mini sketch right here, okay, we've got our graph and we want to go 4 units to the left and 3 units down. What does that put our vertex at? That's going to be a -4, -3. And we know that that equals h and that equals k. So with our vertex form being y equals a times h minus x minus h squared plus k, we can plug those in. And we don't have an a value, or we don't know if we have an a value, it doesn't tell us. So we're just going to leave that as a 1, which we don't even have to write. So we have x minus -4, which is going to give us a +4 squared minus 3. There is our vertex form. Now if we want to move that into all we have to do is expand that out. Well, remember when we told you about recognizing patterns and how handy those patterns will come in the future? Right here we have a perfect square trinomial. So I know I can square the first term. I can take 2 times a times b, so a times b is 4x times 2 is going to give me 8x. And square that second term, which is going to give me 16. And then I need to finish just filling that out because I have that -3. Combine some like terms, that is going to give me x squared plus 8x plus 13. And there is our standard form. Pretty easy. All right, number 10. What we are given is a vertex and a point. So we know how to find that vertex form when we're given the vertex, but now we want to make sure it goes through a point. Well, we know that this equals h and k, and we know this is an x and a y value. So the first thing we need to do is, without even knowing what our a is in our vertex form, is go ahead and write x minus 1 plus 2. That's going to be, oops, sorry, and we have to square that. That's going to be vertex form, but what we want to do is find this a. We're solving for a, and luckily we have been given an x and y. So we're going to write that as 10 equals a times 3 minus 1 squared plus 2, which is going to give us a times 2 squared plus 2, bring that 10 back down, which will give us 4a plus 2. Take that 2 from both sides. That gives us 8 equals 4a. Divide both sides by 4, and we get a equals 2. Now we have our a, we have our h, we have our k. We can write that out. 2 times x minus 1 squared plus 2. And if you were to plug that in to your calculator and do a table, you would see that when you input 3, you get 10. Go ahead and pause it again. Do number 11 real quick and come back and check your answer. All right, you should have gotten y equals negative 2 times x plus 2 squared minus 4. Remember, that becomes a plus because our h is a negative. It brought a negative with it, turned to a positive. Okay, let's go one more step. Let's take our standard form and rewrite that in vertex form. Well, right now what we know is a, and a equals 2. What we're looking for is h and k. Luckily, because of 8(3), we know how to get h because h actually equals x, and we find x by taking negative b over 2a, which is going to be negative 8 over 2 times 2, which will give us a negative 8 over 4, which is a negative 2, which is a positive 2. And because x equals h, we now know that h equals 2. And to get that k, which equals y, we plug this 2 back into our original function, which is going to give us 2 times 2 squared minus 8 times 2 plus 4, which will give us 2 times 4 minus 16 plus 4. Sorry, I'm running out of room. Which will give us 8 minus 16 plus 4, which is going to equal negative 4. So now we know y equals k, but we want to call it k. K equals negative 4. We have our a value, we have our h, and we have our k. That will give us y equals 2 times x minus 2 squared minus 4. That is all we're going to do for tonight. Go ahead and work on 13 on your own. We'll take a look at it tomorrow. and look at the back of the page. We're going to do this in class, which I don't have, sorry. We're going to do the back page in class. We will talk about that tomorrow. And it's a lot like numbers, let's see. You can use number 7 and 8 here for reference. That'll help you do that back page, and we will do those in class tomorrow.